This video will illustrate how to solve a rational equation by eliminating the denominators. So this is actually a very simple skill. Now a problem like the two that I'm checking could simply be, you could simply use extremes means. And that's an old skill, everyone's capable of solving that. In an effort to give you a new skill to work with, I would like to introduce something solving by what's called the LCD method. So you identify the common denominator, and let's look at R, letter R. Here the LCD would be 20. So if you bracket the entire equation and multiply by the common denominator over 1, multiply each term by the common denominator over 1, and I'll show my support work below. So what's going to happen? I'm going to have 20 over 1 times x plus 3 over 4. So what's going to happen when I compare 4 to 20, the 4 would simplify away, leaving you with a 5. So the first expression becomes this. And then comparing it to the second expression, 20 over 1 minus 2, that's simply going to be 40 minus 40. And then the third expression, if I compare the 5 to the 20, simplifying the 5, what would remain behind would be a 4. And I would set this equal to 4 times 5x minus 2. And then I would carry on and just simplify that. It's a nice, simple problem with a single variable. Actually pretty easy to do. So what we're doing is we're taking these fractional equations and we're turning them into equations without fractions. We're actually eliminating the denominator. Let me set up a few more. Once you get the problem set up, you should be able to take it from there. But let me illustrate a few more on the video just to give you some confidence with the skill. So let's look at, let's look at n. So here, letter choice n, the common denominator would be 6. So you bracket the entire equation and multiply it by the LCD over 1. When I compare 3 to 6, what would remain behind would be a 2, and then the 2 would be filled on top, so I would end up with 8x. If I multiplied the second expression by 6 over, its denominator already is 6, so if I'm multiplying by 6 over 1, the only thing that would remain would be the numerator 2x plus 3. Notice that the two expressions have been subtracted, so that fraction bar acts as its own grouping symbol, so I would need to subtract the entire expression, both terms in the expression. And then lastly, dividing that out, what would remain behind is a 3, and 9 times 3 is 27. So I've taken the equation with fractions in it, I've eliminated the fractions and turned this into a nice, simple, basic algebra equation that anyone can handle. Single variable, simple equation to solve. And let's look at one more in the video, and that's probably going to be enough to give you the confidence to carry on with this. Let's see, let's look at letter T. The common denominator here would be 24, so the LCD here is 24. Multiply the entire equation by 24 over 1. Comparing to the first, what's going to remain behind is a 4. So the first expression becomes 20x. Second expression, notice that I'm subtracting. When I compare 8 to 24, what's going to remain behind is a 3. So this is going to be 3, and I'll go ahead and I'll bracket the whole thing just to make sure that this is 3 minus x with the additional factor of 3. And then I would set this equal to, when I compare 12 to 24, 2 is going to remain behind. And now I have a nice simple equation to solve. Let me do just a little bit more support work on the side just to make sure that you understand that this actually does work and it doesn't change the value of anything. If I take the expression 5x over 6 and I multiply it by 24 over 1, what would remain behind would simply be a 4, and then I would be left multiplying 5x times 4. Since the denominator of 24 is 1, there's really no effect with that, and all that would remain is the current numerator and the factor that was missing. So let me do one more. Let's do the next expression together. if I were to take this out and do it in pieces, I've got 24 over 1, and I'm going to multiply that times 3 minus x over 8. And then once again, the fraction bar acting as its own grouping symbol, so that stays intact. When I compare 24 to 8, dividing that out, what would remain is a 3. So once again, I would have the current original numerator, and I would multiply it by the factor that was missing from the original denominator. I've eliminated the denominator, but what remains behind is the missing factor. And then let me do the support work for the third term, just to make sure that everyone understands. So here I have 4x plus 3 over 12, and I'm multiplying this by 24 over 1, grouping my numerator together, comparing 12 to 24, what's going to remain is a 2, and then I would simply be left with the original denominator multiplied by the factor that was missing in its denominator.